Chapter 7, Modern Welding Railway Track. Introduction. Mentioned earlier the rail joint, the weakest link with the rail track of the L with the effect of the rail joint well known, and include the fact of the track with the joints require the 30% extra maintenance work compared with the plain track. The best remedy for the problems caused with the rail joints lie with the welding of the rails introduced with the number of the joints and joins extensible path of the bottom weld of the railway track and incorporates the systematic welding repairs, which provides potential to carry the trains faster and provide better riding conditions. Reduce maintenance cost of the following terms are commonly with respect to welded tracks. Long welded rails, or LWR. Long welded rail is welded rail with a central portion does not undergo any longitudinal contraction expansion due to the temperature variations of thermal expansion. Normally, the rail length is greater than 250 meters broad gauge or 500 millimeters meter gauge, as functions as a long welded rail. In the Indian setting, the maximum length of the long welded rail is normally restricted in one block sections. Figure 17.1 shows the long welded rail, switch expansion joint, total length of the long welded rail, non-breathing length, breathing length, and switch expansion joint. Continuous welded rails. Continuous welded rails, CWRs, is a type of long welded rail that continue through the station yards, including points of crossing. Short welded rails, or SWR, is welded rail with contracts expand throughout the length. The breathing length is the length of each of the long end of the long welded rail that is subject to expansion and contraction account with the variations of temperature. Anchor length. The anchor length is the length of the track that is required to resist with the pull exerted with the rail tensor on the rails. Switch expansion joint. The switch expansion joint, or SEJ, is the expansion joint within itself of the end of the long welded rail to permit the expansion contraction of the joint and bring the breathing length due to the temperature variation. Buffer rails. Buffer rails are set rails provided with the end of the long welded rail to allow the expansion contraction breathing length due to the temperature variation. Distressing is an operation undertaken without using the rail tensors to attain stress-free long welded rails to specified rail temperature. Rail temperature. The temperature of the rail is recorded and by approved of the rail thermite is assigned with the difference of the ambient temperatures with the atmospheric temperature as reported meteorological department. The main rail temperature. TM means the rail temperature of the section, the average of the maximum minimum rail temperature recorded with the section. Installation temperature, the average of rail temperature achieved with the rail to the last into sleep at the time of the installing long welded rails. Standard installation temperature, or TS, is the installation temperature as in the standard gap of the 6 millimeters provided with the fish joint plate. Prevailing rail temperature, TP, the average being prevailing temperature of the rail at the time of any operation connected with the distressing being carried out. And stress-free temperature, TO, the rail temperature is which the rail is free of thermal stress. Distressing temperature, TD, is the average date rail temperature at the time of the fastening rail and sleep with the average distressing of the long welded rail without using rail tensors. 17.1 Development of the welded rails. Indian railways keep the place with advanced railways of the world adopted welded rails. The last few decades of development of welded rails have been necessary due to economical consideration coupled with the technical advantage of the welded rail. The fish-plated track with the rails will initially weld within the panel 3 to 5 to 10 rails. The development of these rails is called by the short welded rail panels, or SWPs, or short welded rails, SWRs. The first stage of the development of welded rails is country due to the course of the time there were with a considerable achievement of the track technology and new concept of locking up the stress of the rail, which thereby resisted any change of the length of the rail was developed. According to the long welded rail, the varying length of up to 1 kilometer were laid in eliminating the rail joints to making the most of the advantage that the welding offers. The concept of the continuous welded rails is normally developed and rapidly welded rails are being laid continuously so that they get full advantage of the jointless track. 7.2 Theory of the long welded rails. Is well known metal expand with contraction and creep the degrees temperature undergoing thermal expansion. Rail expands and contracts depending on the variation of temperature. Expansion for the rail is functionally coefficient to linear expansion of the rail material. Length of the rail, the variation of rail temperature. Normally the free rail will undergo the alteration of the length of the corresponding with the variation of the rail temperature, but as the rail fastens to the sleepers, which in turn embedded with the valve, their expansion contraction due to the temperature change with the restricted restraint of the put on the thermal expansion rails give the rise to locked up thermal stress in the rail metal. The resulting force known as the thermal pressure thermal force is given by the following equation: P equals E times A lowercase a t. P is the force in tons. E is the modulus elastic rail steel of 2.5 times 10 to the 6 kilograms a centimeter squared, or 2150 tons a centimeter squared. A is the cross section of the steel of centimeter squared squared, depending upon the individual rail length of 52 kilograms is 66.515 centimeters squared. Your A is the coefficient linear of the linear expansion of 0.00000152 per Celsius degree of temperature is given in Celsius. Substitute the values of EA, and A and T with the force of every 1 degree rise of temperature of 52 kilograms can be derived as 1.638 tons per degree Celsius. The values of E and A are fixed for each type of the rail steel with the value of the cross section and ES area that depends on the section weight of the rail. Substituting the value of the section weight with the kilograms and meters. The force P in tons can also be given in the formula P equals 31.5 times AT. A cross section of steel in centimeters depending on and temperature variations Celsius. Where P is the force in kilograms, A is the section of the weight of the kilograms, and meters, T is the temperature variation in degrees Celsius. You get 1.6838 tons per degree Celsius. 1721 longitudinal thermal expansion along welded rail breathing length. In case of the long welded rail, the thermal expansion rail take place with the rail end because of the temperature variation and inability of the resisting force off of the rail and ballast to overcome the same. Long welded rail continues to expand, ends up to the particular length with the adequate resisting force developed and toward the center of the stage, but finally reaches the particular length of the rail at its end where the resistance off of the track structure becomes equal to the thermal forces created with the result of the temperature variation. This alteration of the rail length beyond this point, the cumulative value of the expansion and contraction of these end points portions of the rail is breathing lengths as given by this formula. So far as SL is equal to L over AT and divided by 2, where SL is the amount of the expansion contraction of the rail, L is the breathing length of the rail, A the coefficient of thermal expansion of the rail, T is the variation in temperature. The value of expansion of the contraction of the rail is half the value of the would have been attained by the rail if it had been free expanded with the rollers with a ballast resistance. Alteration length of the confined to only the certain position of the portions of the long welded rail, the center portion of the long welded rail where their force constantly immobile does not undergo any of the changes in length. Portion end of the long welded rail which undergo the thermal expansion is called breathing length. On the Indian Railways, the length is equal to about 100 meters at either end of the rail in case of the big broad gauge tracks. Alright, example 17.1. Calculate the minimum theoretical length of the long welded rail beyond which the center portion of the rail will not be subject to thermal expansion given the following data. But the cross-sectional area of 52 kilograms section of the 66.15 centimeters squared, the coefficient thermal expansion rail steel of 11.5 times 10 to the negative 6 per 10 to the negative 6 power per degree Celsius temperature variation, 30 degrees Celsius modulus elastic rail with a steel of 2 to the times 10 to the 6 kilograms centimeters squared. Sleeper, the spacing on the 65 centimeters with the average restraining force per sleeper per rail, 300 kilograms. Using the equation, the given value of the thermal force of the P is given with the P equals to 2 times 10 to the 6 times 66.15 times 111.5 times 10 to the negative 6 times 30 is 45.6 tons. Resistance offered per sleeper is equal to 300 kilograms or 0.3 tons. Number of the sleeper that required with restraint of the force of 45.6 tons. Or 152 sleepers at each end. The breathing length of the end of each of the sleeper spaces is 60.65 meters, or 98.8 meters, 100 meters approximately either end. Total breathing length for both sides, presuming the zero portion in the center, 100 times 2 meters is 200 meters. Therefore, the minimum theoretical length of the long welded rail is 200 meters. Alright, 7.3. Prohibition length, prohibited location of the long welded rail. Due to the technical problems arising in account of the using long welded rails, the Indian Railway has specified location of the laying of the long welded rail is prohibited. These locations are listed below. New construction double lining of the formation of the track is not fully stabilized. However, the mechanical compaction of the earthwork design along welded rails may be laid on new lines in initial stage within itself, approved with the chief engineer. B. The location where the rails are subject to the heavy wear, corrugation, corrosion of the required frequent renewal. Location with the formation weaker, the track deformation extensive with its lead, the buckling. Location formal, suspectability, popping of the ballast and likely to give heavily contaminated, thereby necessity the frequently open tracks, degrading of the ballast. Location with frequent breaches, flooding, the subsiding may occur, and the curve of the radius sharper than 500 millimeters. In this case, the reverse curve of the light limit value of 1500 meters. The steeper the gradient parameter, the longer the welded rail is 1 in 100, and every change of the gradient vertical curve should have the minimum radius of the table 1711. A has a minimum radius of Group A has a minimum radius of 4,000 meters. Group B has a minimum radius of 3,000 meters. Group C, D, and E has a group of 2,500 meters, and all meter gauge routes have 25 meter minimum radius. 17.4 Track structure of a long welded rail. Minimum length required for the rail's function along welded rail depends upon the range of the temperature variation. Section rail with the resistance offered over the ballast, thermal expansion of the sleepers, resistance offered by the rail and sleeper assembled with any with the thermal expansion for the rail. Normally a rail length of about 100 meters of the broad gauge, 150 meter gauge subject with the thermal expansion each within the rail. The length of more than 200 meters of the broad gauge and 300 meters of the meter gauge generally necessary for the welded rail. Panel functioning limited as long welded rail. 17.4.1 Formation. The formation should not pose any problems with the long welded rail. Stretch with the weather. If the formation is bad, it should be stabilized before the long welded rail is laid, as the cross slope of the 1 to 40 should be provided with the time of the screening leg of the long welded rails. In case of concrete sleepers, tracks, an extra provided to the extent of 90 centimeters for the embankment, 60 centimeters for the cuttings. 17.4.2 The ballast. The clean ballast cushion minimum depth of 250 millimeters or 10 inches should be provided with the bottom of the sleeve of the long welded rails in order to increase resistance. That the shoulder width of the ballast should be measured with 350 millimeters for the case of straight tracks, and inside of the curve 500 millimeter case outer end of the curve of the ballast should be humped up to the height of the 150 millimeters both shoulder. Typical ballast profile of a long welded rail, single line with a double line broad gauge concrete sleeper track with 250 millimeter 10-inch ballast check construction cushion are figures 17.2, 17.3 respectively summarized table 17.2, 17.3. 17.2 shows the ballast profile of single line long welded rail track, all dimensions millimeters, 6,100 millimeters from embankment to embankment, and 5,490 from cutting. 2360 and 2510 1 in 40, 100 meters from the 100 millimeters, 350 millimeters from the sleeper, 1676 from the inside of the gauge of the track, 500 meters off the end of the track of the 100 millimeters slope. Ballast profile, single line, broad gauge, wood and steel, concrete, wood, meter gauge, ST, CTS, and concrete. 17 ballast profile, double line, weld track, broad gauge, wood, steel, concrete, wood, and meter gauge, ST, CTS 9, and concrete. As followed the non-long welded rail track. The ballast section of the net up of the long welded rail track should be continued over the switch expansion joint buffer and assembly. Also use the rail lengths beyond it. 17.3 shows the ballast of millimeter in a double line longer welded trail track, 10,210 millimeters embankment, 4,725 meters from the cutting, 23,900, 2,390, 20,400, 1 in 40, 1,676 inner gauge over the track, 4,720 from center to center track, 500 off the ends of the sleepers to 100%, 100 meter slope, 350 meters off the other side of the short side of the ballast. Alright, 17.4.3 Sleepers prescribed in the long welded and continuous welded rail. Sleepers prescribed in the long welded rail and continuous welded rail are listed below. Broad gauge concrete sleepers with elastic fittings, untreated with hardening. U category wooden sleepers fastening with a speed of not exceeding 160 kilometers an hour. Steel trough sleeper with elastic fitting with a speed of not exceeding 130 miles an hour as an air measuring the speed of 160 miles an hour. However, the interim merit measures steel sleeper with loose for jaw keys and untreated wooden sleeper. The CTS sleeper is also permitted. Sleeper density of the broad gauge track with the sleeper the density of the long welded rail and continuous welded rail shows as follows: greater than 20 million gross tons, 1,660 sleepers per kilometer. All routes except E route with a 1,540 sleepers per kilometer may be permitted. From gross mill tons from 10 to 60, 1,660 sleepers per kilometer for the route A, 1,540 per kilometers per route B, C, and D and E. Less than 10 gross millimeter tons, 1,660 sleeper per kilometer route A, 1,540 per route B, C, D, and E, 1,310 per kilometer route E with a 1,504 kilometer long welded rail. Meter gauge. The prescribed sleep of the meter gauge is concrete sleeper, the troughs, and steel troughs, sleeper, the durable wooden sleeper, the CTS9 sleeper, sleeper density meter gauge. A meter gauge track with sleeper density should be 1540 sleeper per kilometer, standing at 100 kilometers per hour, with a 1660 sleeper per kilometer speed above the 100 kilometers an hour. Existing along welded continuous welded rail. The decision retaining chain with existing sleeper density is taken to the chief engineer. 1744 rails. Long welded rails should be laid with 60 kilogram, 52 kilogram, 90 R rails, built broad gauge 90 rails, and S55 rail gauge, meter gauge bearing portion of the already laid with the 60 rails, 60 R rail. Generally, new rails, fishbolt should not be used in long welded rail. Further level crossing should not be followed within the breathing length of the long welded rail. Switch expansion joints and buffer jet rails should be located at the end of the long welded rails. Alright, 17.5 rail temperature measurement. The rail temperature in the rail with the record with the rail thermometer type of the northern Indian maximum rail temperature summer with about 20 degrees Celsius above the maximum, so ambient temperature. Minimum rail temperature is about 2 degrees Celsius, 3 degrees Celsius below the minimum ambient temperature. The tracking of the Indian rail is geographically divided in 4 rail temperature zones as following criteria. Zone 1, 40 to 50 degrees Celsius. Zone 2, 51 to 60 degrees Celsius. Zone 3, 61 to 70 degrees Celsius. Zone 4, 71 to 76 degrees Celsius. The meaning of the annual temperature is the average maximum of the minimum rail temperature during the year. The value of the TM or the rail temperature, annual rail temperature, depends upon the range of the temperature. The maximum minimum rail temperature for the 1 year should be recorded in order to determine the annual rail temperature. Although the recorded 5 years is preferable, the rail thermometers are used to measure the rail temperature. The different type of thermometers available in Indian rails are following: embedded type, dial type, continuous recording type. Most commonly used among these are the embedded type thermometer. The type of the thermometer consists of the ordinary thermometer insert with the cavity of the piece of the rail head. The cavity is filled with the mercury and sealed with the rail plate piece containing the thermometer existing in the same conditions as the rail track. Thermometer recorded by the thermometer at the time of the rail temperature. It takes about 25 to 30 minutes to record the rail temperature. 17.4 shows the embedded type of the rail thermometer. Seal the thermo bulb mercury bath. A piece of the rail head, mild steel centigrade, and thermometer reading of up to 100% in the handle. Alright, your maintenance long welded rails. Some important points for the general help of ensuring the safety and effective maintenance of the long welded rails are following: the well-compacted ballast bed should be available below the sleepers at the time of giving adequate lateral longitudinal resistance of the track in order to prevent buckling, excessive alteration, sleeper length of the long welded rail. The track should be left disturbed as far as possible. Only essential track maintenance work should be carried out in temperatures close to the distressing temperature. Regular maintenance should be completed well before the onset of the summer, combined with the hour of the rail temperature before temperature minus plus 10 degrees Celsius. The track should be preferably maintained mechanically without on the track of the tamping machines. At no time during the manual maintenance should be more than 300 sleeper space be open continuous stretch between two stretches with 330 sleeper length and fully boxed. Packing on the renewal single isolated sleeper that may be done with a gang mate provided with at least 50 sleeper space on either side of the left untouched for the minimum of the 24 hours after such work is done. 17.6.1 Special equipment that maintenance long welded rail. Staff should be allocated with additional equipment detailed below with the systematic maintenance of long welded rail for emergency and additional equipment of the gang. The prepared jog fish plate with a special clamp, 30mm long weld closure space, rail thermometer marked with the temperature range, special 1 meter long fish plate with the clamps. Additional equipment of the PWIs or protection the inspectors, the sufficient number of the jog fish plate clamps, sufficient number of the rail thermometers, 1mm, 10cm long straight edge caliper feeler size gauge of 1mm to 2mm, special 1mm long fish plates with the clamps, rail sawing machines, equipment, thermite welding equipment, de-stressing, punching, and a hammer. 17.7 Switching expansion joint. Switching expansion joint is the device installed with a long welded rail to allow the thermal expansion of the breathing length, presuming the breathing length of 100 meters of the broad gauge track. The maximum temperature variation plus or minus 35 degrees Celsius from the main temperature for the India breathing length of the wood shifts and move by the approximate 20 plus or minus millimeters of the means of the position switch. The expansion joint type of the design accommodated the total length with modification of plus or minus 60 millimeters. The external allowance has been made to carry out the like of the currency of the factors fractures in the breathing of the length of the creep of the wrong proportion of the position of the SEG or switch expansion joint situated with the end of the long welded rail after the length of the 1 kilometer or so. The points of the face direction in the case of the double lines in the direction of the heavier traffic in case of single lines. 17.5 shows the switch expansion joint weld the gap is joint the means of the position tongue rail, the means of the position of the sock rail, the preference rail post. 17.8 buffer rail. The buffer rails can also be used at the end of the long welded rail instead of the switch expansion joint buffer. The rails are ordinarily railed are high, much higher standard with respect to the proper line with the fishbone bladed joint and proper gap between the rail joint ends and gap of 7.5 millimeters left at each end of the buffer joint. End of the buffer rails should be even against each other. Thermal expansion to permit the free expansion of the contraction buffer. The rails are laid on the wooden sleeper with the MS candidate with the bearing placed 22 millimeters diameter rail screw with a portion of the long welded rail bare with the buffer rail should be maintained by measured shovel packing. Only the buffer rail should be used at the end of the long welded rail only with a switch expansion joint is not readily available. The use of the buffer rails or discontinued interval rails because of the difficulties encountered with the maintenance would reversely affect the safety of the train. Alright, your short welded rails, SWRs is welded the rail undergo the thermal expansion throughout this length of the rails and encompass 3, 5, and 10 rails welded together. Expansion of the Indian rails, short welded panels of the more three rail lengths produce excessive thermal force. This phallic struggle the effect requires the proper maintenance but cannot be economically technically justified. Short welded rails of 3 lengths, 3 times 13 millimeters broad gauge, 3 times 12 millimeters 4 meter gauge for there has been standardized Indian rails. Alright, 17.9.1 track specification short weld. The Indian rails enumerate the following specifications for the track to be welded in short welded rails. Foundation alignment of the short welded rails should be laid with a stable, efficiently drained formally and should not be laid on track curve sharper than 3 degrees on metal concrete sleepers, 2 degrees on wooden sleepers in case of the broad braid gauge track. In the case of the meter gauge track, it should not be laid with a curve sharper than 5 degrees on metal concrete sleepers and 3 degrees on wooden sleepers. Rails only new sleepers of good quality. The second-hand rails may be used with short welded rails. Minimum rail section specified 3 panels, 90 R broad gauge for track and 60 R with a meter gauge as following temperature zone. However, the 60 kilogram rails should be, be laid as 3 by 13 millimeter short welded rail panels. Temperature of zone 1, 2, and 3. Sleeper density. One of the following type of sleepers should be used as a short welded rails. The wooden sleeper with the anti-creep elastic fitting of the cast iron sleeper with the key type of elastic fitting of the steel throw off the sleeper with the key types of elastic fitting. Concrete sleeper with the elastic fittings. Wooden sleepers should be preferably be used in all fixture plated joints with short welded rails, or to be laid metal sleeper that there is preferably provided with the MS bearing plate with a non-anti-creep fastening. Minimum sleeper density be specified in the broad gauge meter gauge track of M+4, except for the case for the 60 kilogram rails of the broad gauge track, which would be M+7. Ballast. One of the stone ballasts should be used in the short welding rail. The minimum ballast cushion below the sleeper there should be 200 millimeters both on broad gauge and meter gauge, and an extra 100 millimeter width of the shoulder ballast over and above the standard ballast section of the straight track should be provided with the outer edge with the curves. 792 regular maintenance of the operation short welded track. The regular track maintenance working including all the operation involved in the packing, lifting, and lining with local adjustment of the curve screening with the ballast for other than deep screening. The scattered renewal of the sleepers may be carried out with the restriction when the rail temperature is below TM plus 25 degrees Celsius. A major lifting a major rail line of the track depending on the screen with the renewal of the sleeper continuous length of should be normally done with the rail temperature below TM plus 15 degrees Celsius. After suitable precautions have been taken, it becomes necessary to undertake the net rail work of temperature exceeding TM plus 15 degrees Celsius. Adequate speed restriction should be imposed. Alright, 710, continuous welded rail. On Indian rails, length of the welded rails has been limited to only 1 kilometer to take into consideration conveniency, length, distress, maintenance. Welded points along within 1 kilometer have also been traveled to know that the continuous welded rails. Such rails have been laid with the station, but conventional installation rails and turnouts have been left out in an isolated switch with expansion joints. Trails along welded and continuous welded rail passing through the points or the crossing also progress. The theory behind the continuous welded rail is the same for the long welded rails. Once for the concept of the locking over the longitudinal thermal force is accepted that there is no reason the length of the long welded rail should be limited to only 1 kilometer. However, the switch expansion joint buffer joints are provided that every 1 kilometer of the long welded rail have the source of the weakness of the track requiring heavy maintenance that would avoid the effect of the continuous welded rail will lead with the station to station. In the fact that the European railways, particularly German and British railways, long welded rail, continuous welded rail have been laid for several years miles together without inclusion of the special expansion joint switch expansion through the station yards. It's an important feature of the switch short welded rail, long welded rail, continuous welded rail in table 14, 714. Alright, you have your 1711 buckling of the track. Rail track liable to distort, particularly with the hot weather. The compressive the force of the trail exerted with the lateral longe resistant track of the buckling track measure of the grave concern with the long lead derailment of the even of the serious accident. Alright, 1711-1. Track can be buckled due to the following reasons. Inadequate resistant track due to deficient ballast, ineffective missing fastening length, distressing maintain the raising track with the outside of the specified rail temperature range, especially in hot weather. Failure to lubricate the special switch expansion joints and time, excessive creep jam joints and suction portion of the welded track. 711-2. Buckling track may be noticed for the track displaying with the following symptoms: presence of the kink of the track, absence of the gas short welded rail portion of the track with the mornings out of the day, expansion contraction switch expansion joint with a plus or minus 20 millimeters more than the theoretical range for the given long welded rail manual. However, the high percentage of the hour sleep are the precautions. Buckling can be avoided by taking the following precautions: proper expansion of the joint is specified with the manual should be provided with the short welded rail portion track. As buckling likely occurring between the 11th and 17th hour of the day, the rotors of the keys should be also adjusted that their proper patrolling of the low welded rail portion of the track temperature exceeding the temperature of plus 20 degrees Celsius. No work with the traction motor included with the packing leg with the lining made for the minor realignment. Traction and screen with the ballast should be done outside of the specified temperature. Whatever the truck sham structure is vulnerable to buckling, intermediate extra be taken the strength of provision, extra shoulder ballast, increasing slippery density, provision with adequate anti-creep fastening, replacement and tightening of the missing and loosening of fastening, etc. 1711-4 actions. As soon as the tendency towards the buckling is detected with the track, traffic should be suspended. The track should be fully protected. With the track should be stabilized, keeping of the ballast to shoulder up to the top of the web of the rail. When the buckling takes place with the traffic, should be suspended. Remedial and work should be carried out with the following stages under the personal supervision of the inspector. Temperature of the rail is brought down with the permissible pouring water on the rails. Emergency of the permanent rail repairs, distressing should be carried out as specified in the long welded rail manual. In this case, fish bladed short welded rails, the general reserve curve may be provided with the rear of the buckled track of the eve of the stress. The buckled rate then can cut out the two plates with more than 4 millimeters apart. There should be smoothed and corrected alignment of the rails with the required length should be cut and inserted with the close of the gap. Short welded rails. A rail with a welded pan with a 2-3-5 of the rails. The short welded rail, the entire length of the rail is subject to the expansion and contraction due to the change of the temperature of thermal expansion. In the case of long welded rails, however, only the end of the portions of the rail are subject to thermal expansion. The center portion of the long welded rail remains clamped down, undergoing any change of the length. The continuous welded rail are rails welded in the length of greater than 1 kilometer. Longest welded rails and continuous welded rails are part of the modern high-speed tracks require very little maintenance compared to the fish plate tracks. Alright, Chapter 8, Track Maintenance. Chapter 18, Track Maintenance.